All right, well, welcome to, I guess this is one of the first breakout sessions here at the meeting. We'll be talking about metadata, trying to get beyond basic discovery metadata, particularly in the context of the Cross Domain Interoperability Framework. This session is sponsored by the RDA Metadata Interest Group, this being of metadata interest. We'd first like to acknowledge and celebrate First Australians on whose traditional lands we meet. We pay our respect to their elders, past and present. So, just some context about RDA. Welcome to new members, anyone who's new here. There are 6 guiding principles at the heart of RDA. You see them up here: openness, community-driven, consensus, nonprofit, technology-neutral, harmonization, and inclusivity. And we are trying to work within that framework here. So the Metadata Interest Group was established back in 2013 and has had a number of activities on and off over the years. The important outputs so far have been a document about metadata principles and their uses, recommended metadata element set, and metadata standards catalog. And we'll be building on that foundation, I think, in this cross-domain interoperability framework that we're talking about here today. So the goals for this session are we're trying to explore how we can extend basic metadata to more fully support fair data. So the findable part of the metadata workflow, I think, is fairly well understood, and a lot of people, there's a lot of common ground there. But the question is, how do we deal with more complicated issues that we need to be able to document for truly fair data? So things about data access policies. How do you deal with personally identifiable information and security issues? How do we better document provenance and quality? How do we document data structure to use the metadata for machine actionable connection to real data sets once they're found? And how do we deal with domain-specific semantics? One of the big problems is as you get more and more detailed in specific domains, there's more and more information. There's room up here in front. So these are the issues we'll be working with. Our agenda is we'll start with a short overview of the Cross Domain Interoperability Framework from Simon, and then talk a little bit about documentation for data set for data integration, how to deal with this extensibility problem. They'll follow that. We'll have a short discussion. Particularly, we're interested in input from the audience about complex kinds of data that you have to deal with that aren't very well accounted for in existing metadata schemes. Then we'll move on. Steve McEachern will talk about dealing with sensitive information and the ODRL rule language to automate data access. And finally, a case study dealing with genomic data. And at the end, we'll have another short period for discussion. Hopefully, there'll be time, and then a wrap-up. So without further ado, let's launch into the first section here. Simon, all over to you.
Thanks very much, Steve. Hello, everyone. I'm Simon Hodson, Executive Director of CoData. So I think it's very interesting that this session is about modularity of metadata schema, and that's something that we tried to do with the Cross Domain Interoperability Framework. The Cross Domain Interoperability Framework is a work in progress. It came out of the World Fair project, which was a European Commission-funded project, and was first published just over a year ago. But there's work ongoing in the context of ongoing CDIF working groups and in relation to a number of funded projects, so I'll talk about that. So what is it? What did we try to do? It is categorically not a new standard. We didn't start at brass tacks or at point zero and try to recreate and redefine another standard. We're trying to avoid falling into this trap, which is so eloquently described by that XKCD cartoon. We're not creating another standard. What we are doing is identifying functional requirements for data integration in relation to the FAIR principles, but not necessarily slavishly following the FAIR principles, identifying and pointing to existing domain-neutral standards that can serve a useful purpose in meeting that functional requirement, recommending those standards, and then describing for practitioners how to implement them. So what we want to achieve with CDIF is a set of useful recommendations and a playbook. Useful recommendations using domain-neutral standards and a playbook for how they're implemented. So CDIF as it is, that came out of the World Fair project, comprises 5 profiles. In CDIF, by a profile, we mean a set of recommendations and implementation guidelines that meets or addresses the needs of one of those functional requirements. So what we got through so far is data discovery, some recommendations about that. Access, some basic recommendations on using ODRL. Controlled vocabularies, basic recommendations on using SCOS. Data description, recommendations on using the Data Documentation Initiative, DDI's, Cross Domain Integration Standard, and how to implement that for data integration. And recommendations on universals, which are often the connectors between data sets, time and place, but also other important shared things like units of measure. So, it's a modular approach. It tries to address particular needs. It tries to address those needs by pointing to domain-neutral standards and describing how you can use them. The first published report, which was the output of the European Commission-funded project, is there with the DOI, but we then translated that into a playbook, an online playbook, which is at that URL there. So I'll go into a little bit of detail on 2 of those profiles, the discovery profile and the integration profile, and describe what they will do. And other speakers will address the access profile and talk about the integration profile in further detail. So the discovery profile. One might ask, is there anything more we need to say about data discovery? Well, yes, indeed. It recommends a content model, a set of fields for discovery metadata. It recommends the JSON-LD serialization. It points to a schema.org vocabulary to use and a mapping to DCAT. So all of this is in line with what we felt through the World Fair project to be current good practice. Schema.org and JSON-LD are widely used by Science on Schema.org, by the ODIS Ocean Data Information System. But there's an additional important recommendation, which I think is fundamental. It's a small forward step, but it's incredibly fundamental to the objectives of science, and that is to include in the discovery metadata a description of the variables contained in the dataset, so that the user can search not just by a broad subject area, not just by an author or an institution, but also by the variable in which they're interested in. What has actually been observed or measured or quantified or qualified in that data set. So, clear recommendation, use schema.org variable measured in the discovery metadata. And I think a big step forward. The data integration profile is a set of metadata to help decompose and recompose data sets when combining them for that purpose of data integration. Important use case. It could be aggregating lots of data sets of the same sort. It could be integrating data across different disciplines to make a model for heat, urban heat islands, etc. We come across some of these use cases. So there we point to DDI-CDI, which is a relatively new standard, but has been in development for the last few years. And that DDI-CDI contains 3 components, but there are 2 in which we're particularly interested in CDIF. One is the structural description. So how, as Steve's already mentioned, how do you describe the structure of a data set? Is it a tabular wide data set? Is it a long time series data set? Is it key value pairs? Is it a multidimensional data set? And armed with that description of the structure, it becomes easier to decompose and recompose the data set to your needs for that purpose of integration. That's combined with an important feature of DDI-CDI, which is the variable cascade, which establishes a semantic link between the concept, the definition of the variable, and how it's implemented in particular data sets, in particular with units of measure. So that's where we got to at the end of the World Fair project with those 5 profiles, that part of this modular set of metadata recommendations and practical guidelines. The green boxes are the ongoing work to expand the C. diff recommendations, work on context, provenance, process, and, we should say, data quality, looking at mappings which are important for that, combined with data description, and, of course, on the extended access work using ODRL, DPV, and DUO, which Steve, I think, will speak to later, Steve McEachern. So that's where we are now, and we have work in some ongoing projects which is testing the C. diff recommendations, implementing them, and helping us learn from that process. One of those projects is a OSCARS-funded project. OSCARS is a large European Commission-funded project which has a cascading grants scheme. So the project there is C. diff for XAS, X-ray absorption spectroscopy. And quite simply, we're applying the C. diff recommendations, and in particular, the discovery and data description profiles that I've just described, to 2 types of X-ray absorption spectroscopy data, to 2 data standards. One is called XDI, one is called Nexus. The premise is that by using C. diff, we can enrich the metadata, and we can make it easier to discover data that's concerned with the same measurement or the same technique or the same material, and to aggregate that for further research, or to combine data which is in either of those 2 different XAS formats. That project produced a landscape study which looked at the considerable variety of data standards in X-ray absorption spectroscopy. And we will produce very soon, we've nearly finished it, the first mapping of those 2 standards, XDI and Nexus, to C. diff. And that will lead to ongoing work then of how we implement that in practice for that area of research. I'll speed up a little bit to wrap up my short intervention. We're also exploring the implementation of C. diff in a large European Commission-funded project called Climate Adapt for EOSC. That has 3 fascinating case studies, one on urban heat, which I mentioned earlier, one on coastal erosion and overtopping and how you predict overtopping in coastal regions, and another on shrink swell, which is when clay soils either shrink in drought or expand when there's rain, and the effect that that has on the built environment. So if I describe those case studies to you, you can immediately understand how interdisciplinary they are, how they require data from many different sources, some of that data private or sensitive or commercial in one way or another. So we need to address the issues of data integration, and we need to address the issues of legal and organizational interoperability. And then finally, we have a project with the DDE initiative, Deep Time Digital Earth, which will be applying C. diff to DDE metadata, and in particular for the discovery profile that I've just described. And I hope that we'll also be looking at the data description and the structural profile as well. So next steps, while we've been working on those projects, we've let some of the C. diff working groups hibernate, shall we say, a little bit. We'll be rebooting that. We're continuing to explore project and collaboration opportunities, and we have a Darkstuhl workshop coming up which will look at some of those topics that Steve has already mentioned: provenance, context and quality, access, and using that cluster of standards to manage access, metadata mappings and data integration, and some further work on CDIF for XAS, taking the mappings that I've just described and understanding how we will implement those in practice with the colleagues in that research area. So hopefully that's given a brief indication of what CDIF is, where we intend it to go, and some of the ongoing work to test, implement, and refine the CDIF recommendations and profiles. And do I hand back over to Steve? I do.
So moving along, I wanted to talk a little bit about this question about the metadata for data integration. And the goal here is we want to be able to use multiple data sets to produce single unified data sets that we can use for analysis, for research, for answering questions. And so the issues in doing data integration at a very high level are we need to know what are the variables that are represented in the data. We need to know if the way those variables are represented is comparable. Are the values comparable? How to include domain-specific information as we get into more detailed information that is required for doing actual science beyond the discovery level. And then how do we serialize this information so it's it can be operated on? We can make it machine actionable. I'll talk a little bit about each one of these aspects. So at the level of what are the variables in the current discovery profile Simon mentioned, we have schema.org variable measured, which gives us a pretty high-level way of talking about what kinds of information is there in a data set. You can have a name, an alternate name, a description. Probably the most important thing is this property ID that allows you to have an identifier that would ideally link to some sort of vocabulary with more specifics about what the variable is about. And you can have the units of measure for the variable. And this is as far as you can go with schema.org in the discovery profile. So obviously, at the level of actually doing data integration, that's insufficient information to really get beyond the surface level. So this is the question of, are variables comparable between data sets? And this gets where things get domain specific. You need to know things about measurement techniques, context. The context encompasses a lot of various issues. You may be familiar with the IADOPT activity in RDA that's addressed a lot of the information about how you describe variables at a more detailed level that allows you to address these comparability issues. But obviously, this is something that's going to require an extension on schema.org and the CDIF profile. And that's currently work in progress. So how do we deal with the domain-specific information? And we mentioned profiles and this idea of a set of conventions for representing some information for some function. A profile requires defining some vocabulary for what are the properties in the profile, what are the possible values for those properties, a serialization scheme, so how do you actually represent the information in the metadata that's compatible with whatever base metadata scheme this profile is supposed to work with. And a profile also has to have something about requirements. What's the information that's required, what's optional, what's recommended? Those are the typical things. But in order to use a profile for people beyond one or two people, it has to be documented, and there has to be an identifier for the profile. And to really create an interoperable framework, the identifiers for profiles have to be able to be dereferenced to get some kind of useful representation of how that profile works. Ideally, something like an HTML web page for people. Better yet, something like shackle rules or a JSON schema or something like that that provides a machine actionable way to represent what that profile defines. So in this kind of framework now, with all these different domains wanting to add additional information in the metadata for their specific issues, it's an open world situation. So anyone can define new profiles. So how do we keep this from turning into total chaos? And I think one possible solution to think about is, we need some kind of registry so that if you want to describe some data that you're working with, you can go somewhere to say, has somebody defined a profile that will work with this? We mentioned this, the Nexus format. That's a set of, basically, it's implemented in XML. It's a set of what they call application schemes for describing different kinds of X-ray related data. That's one kind of a model for this sort of framework of a registry with a list of profiles for dealing with different kinds of information. And the idea being that anybody can invent a profile if it meets these requirements for the proper documentation and identification, then it can be registered and other people can use it. And profiles that are useful will get used more ideally and profiles that won't. So it's a marketplace kind of approach because there's no big stick that's going to tell people what to do. And these things then would work with interoperability agreements in communities. And again, this X-ray domain is an example where the community has gotten together and said, we have this Nexus framework, let's use that. And people are using it. And it allows them to exchange data more seamlessly. So in the metadata then, what do? So obviously we need some kind of open world serialization. So RDF, JSON, YAML, of course, are good at this. And it means you can extend what's in an instance document, in a metadata document. You can add new fields and stuff without breaking things. Unlike, well, in XML, if you're doing schema validation, it's a lot more difficult to make things extensible. I don't know if any of you ever looked at the extension elements in ISO 19115, but they're pretty hard to use. So then within the metadata, the thing that we're recommending that's important is this idea that you have some, keep pressing the wrong button. And that point is not very good. Anyway, this idea of using this conforms to property in the metadata with identifiers for the profiles that are implemented in that metadata. And this gives a machine agent parsing this record a way to know what kind of content can I expect to find in this metadata, and will it be useful for what I want to do. And the idea being then that these identifiers would dereference into a web page to tell a human what it's about, or into some kind of machine useful representation of what that profile is, if you want to validate things or something like that. So this is in the example stuff we're doing in CDIF right now, this is the approach we're taking. And we talked about the XAS work we've been doing, and this is from one of the metadata records we've generated for that. So that's what we've been thinking about in terms of at a very high level, thinking about the data integration. So the data structure description using DDI is another extension point that we've had to work on. So how do we describe tabular data in more detail? CSV on the web deals with some of that, but more problematic are things like HDF5 or NetCDF, binary formats that are commonly used. How do you document the data structure in to make that interoperable? And that brings us to the first discussion section of this session here. We're interested in what people are thinking about. I mean, what kinds of data are you trying to describe that are difficult to document well using current metadata? I brought up the one the HDF5. I don't know how many people are familiar with that. What other formats are out there that people are using that don't fit very well into existing metadata schemes that you're trying to use? And this is where we're looking for input, feedback. Anybody have any comments or thoughts about that, or questions from either of the presentations so far? Yes?
Yeah, I have a question in general. How do we deal with uncertainty intervals? Measurements are not one number. Measurements are a number plus an uncertainty interval of the measurement. How do we deal with that?
So that's basically in the data representation. So at the metadata level, what you would need to do is say, here's how we're doing that. We have a data value, and we have an uncertainty value associated with that. You could represent that as some kind of object. There's a lot of ways to do it. But the metadata question is, how do you tell the user that that's how you're representing uncertainty? The data provider has to think about, for our use, what do we care about? Do we have just is there a standard deviation? Do we have a maximum and minimum? There's a lot of different ways you can deal with uncertainty, right? But we're not specifying that. What we want to do in the metadata is be able to tell somebody trying to understand that data set, how is uncertainty represented? No simple answer. Simon.
Just to respond to that, said, I mean, I think that is still ongoing work or even early work in what we're doing. We're certainly aware of the need to communicate to any end user what the uncertainty or different terms are used in different disciplines is. IDW or extensions thereof may provide a solution because we could regard it potentially as a constraint on the variable or an additional value associated to the variable that needs to be considered. But that is certainly what we'll be looking at again at this year's Dutch school, and I hope that we'll be able to come out with at least an initial published recommendation for feedback. We are fully aware that that is a very challenging task. There are solutions as Steve described.
Yes.
Thanks. Perhaps this is more relevant to one of the other meetings now, but if you want complex data sets, so there'd be physical artifacts, and then also physical documents where maybe there was a standard format for the card, but people would write all kinds of other information on it, logbooks, some things like that.
So sort of qualitative kind of data?
No,
where it's text-based?
It might be both qualitative and quantitative, but they didn't stick to the margins when they were coloring in the
Right.
in the document.
Yeah. Simon.
Sorry to jump in. Hi, I'm Anthony. It occurs that there is, in the DDI Alliance, there is a quantitative data group looking at an extension for DDI CDI for, sorry, I said quantitative, qualitative data, including physical representations. It might be something you would be interested in. And I have, right, okay, sorry. And I have been asked by that group to scour the community for people who might be interested in joining the qualitative data group in DDI. So get in touch if you, Anthony, or anyone else is interested.
Kirsten. Oh, sorry. Kirsten. Oh. Yeah, Mike's closer.
Okay, thank you very much. So I try to find cases. So for physical measurements, these units are wonderful. But in biology, most of the measurements do not have such a unit. I mean, everything is related to sequence. And of course, you can have fancy stuff and say, oh, a sequence can be measured in Daltons. But from a biological point of view, it makes no sense.
So it's like genomic sequence?
Yeah, this sequence and everything in biology is about sequence. And there is no units. I mean, the units is the code. This is very much the same. Biology is very much the same like in information science. So everything in computer science, in document management, in similarities, these entities, you can have measures like mean average precision or reciprocal ranks. They have no units. So all these words of information in biology, in computer science, units do not apply. Still, we have solid science. So we need to find something else.
So is that, I mean, in for the genomic sequences, that's interesting. So the issue is that the data values are really essentially strings in many ways. Is that? I think the other situation that applies there would be with respect to data that are specified with vocabularies. Right, where there aren't units of measure, there's a vocabulary that you use, and that's, I know in geology that's pretty common, and probably for biology classification, where those, but that's a different thing. Kirsten has the mic. Kirsten?
Yeah, I mean, I wanted to bring up a different data type, so you're familiar with it, which is tabular data that can be of diverse, or I mean, it's heterogeneous in its provenance, and I'm curious to, what I'm specifically coming from are data that are compositional descriptions of materials. And so you can have different variables that have been measured by different methods, but they always reported in a table, in some tabular format. How do you, still ensure the unambiguous linking of the measurements to different methods in the complexity of that heterogeneous data set?
So in the DDI-CDI context, that would be where you have the data points. Each one of those values in that table is a data point, and you would have metadata at that granular level. It gets messy.
Yeah, exactly.
But can be done. Simon, are you taking notes?
I am.
Good. Just wanted to check. Yes.
So I'm just following up what Kirsten has said there, that most of the data that I'll be dealing with, the data that I really care to describe is tabular, probably CSV data, probably in a form that is going to be delivered to the researchers that is hard to describe because it'll include lots and lots of properties from different sensing methodologies, all summarized in a single row. And in order to do that, I'm really interested in how much I can leave DDI, CDI description until later, and worry first of all about some higher level mechanisms such as SSN and SOSA and Provo to describe my data, and then later add a DDI, CDI description based on having solved those problems in my context. But I'd say that for me, tabular data is the most complex data I have to worry about because it is far and away the messiest.
Right. Interesting. We need examples. So behind you, there's someone.
All right. So, Volmar, I work for Elixir Sweden, which is also in biology. I'm using that as an example, but I'm thinking that any situation where you actually have one data set that's actually in reference to some commonly used or commonly agreed reference data set. And I mean, sequencing is one example of where you have inserts, deletions, and things like that that describe what is different from the reference or the common understanding of how a individual in a species works. And there's annotations on images and things like that. So is there a nice way in CDIF to describe, like, this is the reference or the related data sets that needs to be worked on together or accessed together to make sense of the table?
That's a good use case, though. That's what we're looking for. Is that, yeah? So something to think about. Let's talk about that. Steve? We only have the one.
A couple of quick points. Just got to pull those things together. What to say? Yeah, you saw the parts that Simon referred to as the to be done parts here. Certainly, the provenance discussions within there are a key part of that. I think looking at the sequence data, that's a pretty interesting case as well. That would be good to explore. I actually think the qualitative group that Simon spoke to actually would have an interesting basis for exploring that. I worked a bit with sequence data, not in genomics, but actually in social sciences, essentially using the same algorithms, though, but literally they're taken from the genomics, and the sort of sequences are there, and the alignments on the data description are fairly similar as well. But it'd be great to kind of pick that one up as to, I think some of the work that's going on in that group could very clearly feed into sort of the description of genomic sequences. So.
I have another question.
Hi, I'm Christine Laney with the National Ecological Observatory Network in the U.S. And I think one of the struggles we have is that we are collecting genomic data, time series data from instruments, on the ground, observational data, hyperspectral, LiDAR, and it's got all these different metadata standards that we're following. So we work with EML, we work with Darwin Core, we work with schema.org. We get data site DOI metadata, but a lot of our data are collected co-located spatially and temporally. And so when we have all of these different types of data that we're using different metadata schemas for, but we want to tie them together by time and by space so that you can really understand the ecosystem, what's going on over time, I think that's where we run into these complications. And right now we're looking at creating stack metadata for our remote sensing. We are looking at GeoCroissant and Croissant ML. And it's just like they just keep adding and adding. So that's my concern.
Do you have any kind of standard ways that you represent time and space that you use across all those schemes? I mean, most of them have...
the timestamps are just the general, timestamps that you would see anywhere.
Just like an ISO 8601 timestamp.
Right, and then the geolocations are kind of your WGS 84, and we just have lat long, and so you have the spatial representation. That could be a point, it could be a line, it could be a polygon, either way, or tiles if they're remote sensing data.
Other questions? Well, thank you. I think we'll move along then and move into the sensitive data access questions with Steve.
Thanks, Steve. Okay. So I'm going to talk to some of the access section of CDIF that Simon and Steve have been mentioning. This is a very collaborative work that's been going on. And what I'm trying to do is sort of get an introduction to kind of how we're framing, looking at how to bring some of this together within the CDIF framework. And there are a number of folks in this room, and as I say, but particularly this work's kind of led by Darren Bell, who's one of the technical director at UKDS, which is the group that I run. He's kind of chairing that group. And it's sort of an evolution of a long-running conversation that has been going on there. So I'm doing my best to summarise here. Okay, so this is partly drawing out of the CDIF book, which is available. And so I've kind of drawn some of the material from there and trying to connect the dots on some of this. But this was the use cases essentially that we're looking at for automation of data access for sensitive data. And maybe we should put a qualifier on that. There's the can and should sort of questions. Is should you have automated access? Partly thinking, in some of your policies about is it semi-automated? Where do you want human intervention in the process? Becomes part of that discussion as well. So it's partly thinking about how do we appropriately describe and integrate on access models. The questions of how that aligns with policy becomes part of this equation as well. So the cases were essentially a standalone repository might hold personal data and wants to provide secondary access to other research groups. And this is certainly the experience that I've done this in 2 countries, running sort of standalone repositories, enabling access. Sometimes it's an aggregator wanting to provide search clients with filters based on access policies. One of the interesting cases for researchers is, what can I get now and what do I have to wait for? Are you willing to trade off in a sense, what it is you want access to? What's the time limits? Because sensitive data has, obviously has challenges. It also has time delays that come with it. So what are those, what are the sorts of questions there around essentially discovery, but, then the access process that might come with it. Mediating access to data in federated repositories, increasingly we see in a number of countries sort of centralised systems or aggregators at least, enabling access to content from multiple repositories, managing the access brokerage process, for want of a better description. The Chief Scientist mentioned this morning here in Australia, the Office of the National Data Commissioner has essentially a sort of establishing a framework for that here in Australia. And then you might be looking at federated analytics, so access to and analysis of content sitting in multiple sensitive data providers, and that's particularly in the health and genomic spaces. That's a pretty big use case that's there as well. So the proposed approach we're looking at is essentially a combination of 3 things. It's at the core of it is a standard known as the Open Digital Rights Language, ODRL. We're really trying to stick as much as possible with essentially cross-domain or actually web standards for the most part here. So ODRL is a W3C standard, and it's to describe access policies. I'm going to work through quickly a summary of what each of those are trying to do. That's complemented by the data use ontology, which is an ontology that's come out of the Global Alliance for Genomic Health to describe terms of use. Started, oriented very much around health data, but as some of the work that I've done and others have done, there is definitely extensible in a cross-domain framework. And then the data privacy vocabulary, which is another W3C vocabulary for describing legal and risk, legal interoperability, generally, but it particularly has a framework within there for risk concepts and the standard risk management frameworks that you'll see familiar in, in a lot of the risk, management policies that you're implementing manually. So ODRL, essentially ODRL. So this is the stack we're looking at here, and I'll talk about how far along we are as we go through. ODRL is a policy expression language that provides flexible and interoperable information model vocabulary and encoding mechanisms. And the critical part there is the encoding. How do we make this machine interoperable, not just human interoperable? Representing statements about the usage of content and services. So there are 5 core classes in ODRL, and I'm saying this is straight off the W3C description here. Parties, who are actors or agents who can exercise a set of rules, which is permissions, duties, prohibitions. So you can do this, you must do this, or you must not do this, and a policy is a combination of all of those things. Then, based upon those rules, these are the actions you can take, and against assets, our data sets, or actually in the case that we're looking at is data distributions in the DCAT sense, given that you have multiple instantiations and access models for different versions of a data set depending upon the rights and conditions. So the policies then become the structured artefacts, let's say, apologies the way it's appeared on the screen here, that document the above information, and it's a machine actionable instantiation. And that's a critical part here, because what the aim here is that you can have a policy which instantiates an offer, and then a data access process that enables the semi-automation of that offer, of the data request itself. So essentially, this is a simplified version of the ODRL model. Party, the policy. So the policy specifies the functions and the parties. In relation to a specific set of assets, the actions can be performed based upon the set of rules that you have specified. And as a simple example of that, those rules are specified quite often in terms of use. This is available for non-commercial use. For my favourite example is left-handed academics based in Melbourne. Guess what I am. But that's it's the sort of thing you might start to express in a decomposed set of rules, and it's the decomposition becomes the critical part there. So that's the core framework, and that's essentially embedded at the as the W3. So it's operationalised as machine actionable content. But we need a way of describing the usages, the potential usages themselves, and that's where we move to the second part. Duo is the data use ontology, and it was developed by the Global Alliance for Genomic Health. That's GA for GH, and that's an international collaboration. There's participation. My first introduction to this was here in Australia through Australian Biocommons, but Elixir in Europe is a heavy participant within there. There's definitely participation in the North America as well. So essentially, Duo's orientation here is sort of enable, discover, enable the request process, match what it is, the terms of use, against what it is the requestor is actually looking for, and then to enable access, and eventually to enable automated access. And that's the thinking that's here, but you need the instantiation, hence the link between Duo and ODRL as the example. So the framework for this, and this is straight off there's the GitHub repository for Duo, is essentially, the automation process is here's what you can do with it, here's the access request I'm making, and the rationalisation of those two things. Now, you can't automate that entirely in a lot of the models that we have here now. But as a starting point, what you could certainly be thinking about doing is which of those things do we already know, or which of those things can we extract automatically, such that the negotiation process on access could be streamlined much, much more by, I say, focusing on the things that we don't know or that we don't agree on. That's the principle that's there. The third part then is how do we express the legal rights and obligations, and this is where the data privacy vocabulary comes in. So DPV is to provide a data model or an ontology of concepts for interoperable representation exchange of information about processing of personal data and technologies. So it has a core conceptual model, and it's quite extensive. It is designed, for example, to implement GDPR. You know, it's represent in machine actual terms GDPR as an example. I'm picking up here specifically, there's a risk and impact assessment element to this that is really nicely specified out as well. Essentially picking up risk mitigations, consequences, impacts, all familiar terminology if you're working in risk assessment and mitigation, but also thinking about the risk level, security and the likelihood. And so we have a way of, again, expressing in machine actionable terms the risks that we're profiling and be able to act and implement policies that align with that. So the core, again, there's a core DPV model that's there, it's expressed as ontology, and that's kind of an expression of the content that's there. And this is straight off the DPV description from W3C. So we've got three different, sort of related areas there. How do I put all those together? And that's the work that's going on now. And so particularly some work going on in Belgium and collaborators in Europe. Beatrice Estevez, who's based in Belgium, has been looking at this with a number of co-authors. Some really great work happening there. Here's the, mapping to align those standards together and then mapping them within particular, specific instances of data licenses. So some of the work I did here in Australia about 18 months ago, it does line up very, very well with the sorts of expressions we've already got. There's a bit of work to be done in terms of the practical implementation, but the framework there is one that appears to be sound for doing very fine-grained description. So ostensibly, we have a policy about the dataset use can be described as an ODRL offer. A usage request can be described as an ODRL request, and the decision, the agreement, for many of us, the data access agreement can be described as an ODRL agreement. And that's the intent here behind to align this with CDIF, is to get the things you have to do to enable the access process, both at the legal and the legal and organisational and the technical and semantic level, to come together effectively. And this is a simple example that they've got that from some of the paper, the work that Beatrice and others have been doing. There is a proof of concept implementation of this that they produced as part of this, and the next phase of work that we'll be doing is essentially at the Darmstadt workshops in November is actually bringing together how that instantiation might work. So a number of the folks, some of the folks that are here, Beatrice will be joining us as well, is really how do we actually take that from a proof of concept to a implementable framework, and then a pilot implementation itself is really intended for 2026 in a collaboration between staff at my organisation, the UK Data Service, and Odyssey, which is the National Network for Social Science Infrastructure in the Netherlands. And we have a particular case working with TRE implementation across countries that is going to be sort of the example of that. And that's where we find ourselves. I'll pass them along.
Thanks, Steve. We'll have a discussion session following where we'll have questions and stuff. And in the meantime, Milan will be talking about, I think, an application and some of these.
I will talk on, on our real product. We have developed, a product for a national genomic data infrastructure. It is part of European genomic data infrastructure. And first, I wish to talk something about main problems in biomedical data interoperability. One thing is semantic interoperability. We haven't uniform language, and also we have a lot of context ambiguity before you talk about variables. For example, if you have blood pressure, you don't know in this for this blood pressure if a context. For example, if you measure this blood pressure when patients sit down or after exercise, also in laboratory condition, you need to know implicit variables, for example, for some measurement, for example, humidity or other air pressure. So this context is big problem. Also, terminology. For example, if you describe variable, for example, diagnosis with SNOMED CT, it is very good description. If you use, for example, ICD 10 or 11, you lose some semantic context. So this is one problem. Another problem is that we have some format for exchange of data, for example, HL7 and FIRE, for example, but also we have some data models. We have some problems with closed data models from vendors, for example, for some equipments. Also, another problem, especially in Europe, is that every country has different legislation about data privacy. Thank you. This is, I think, and also GDPR is one thing, also informed consent. Also problem is how internal process has been implemented. We have different standards. I will not talk about this. I have a lot of also notes. So if you want, you read after presentation these notes. Important part, a key player is this Global Alliance for Genomic and Health. Why? Because they built technical standards and they built also some policy frameworks for different part of life cycle. For example, from donor how to prepare informed consent to ethical committees, some guidelines for ethical committees, guidelines for secure storage of data, guidelines for data access committees, etc. And also a lot of standards, for example, crypt.gh is one standard for encryption of this biomedical data, standards for workflows, in this biomedical research, etc. Another important factor in our approach is that we work with samples. And BBMRI ERIC is one of research infrastructure in Europe, which brings together all main players in biobanking field, from researchers, biobanker, industries, etc. And they have established guidelines for processes, how to manage these samples, and also legal, social issues and other things. 23 countries is part of this research infrastructure. We are also one of partners. And we use MyAbyss metadata schema for description of collections. On this level, these collections and biobanks and also network of biobanks is used in directory. This is a catalog of sample collections, and you can find some collections from whole European Union. And also, we have also this part on the sample level, some information about sample, donor, events on samples, etc. This is used in Locator. This is real-time search on donor and sample level, and also Finder is used for data analysis. You need, of course, permissions to do this data analysis. We work on other data types, also in MyAbyss, especially on omics, metadata schemas, and on images, metadata schemas. Also, it will be also work on standard operating procedures. Another key player in Europe is European health data space. European Union has adopted this directive in February 2025, and important is that in whole European Union they will establish electronic health registry with for every patient. They will have electronic health records, and important is that this, I don't know what is with, he's coming back. Yes, individual have control over the health data, his health data. Also, clinicians and researchers has possibilities to use health data according to their ethical permissions, and also policymakers have possibility to have access to relevant health information to make better policies on health. Important part for description of data sets is health DCAT application profile. You can find more on this link. It is extension of DCAT application profile with some additional metadata, which are important for cohorts and for some other metadata for description of data sets, health data sets. And another very important, how I say, player is M+MG initiative. And this initiative adopted some standards from Global Alliance for Genomic and Health, and also support whole life cycle from sequencing to searching on this data. They have built an 1+MG framework, and also this M+MG initiative is initiative of, I think, 25 countries in Europe, and they also, how I say, they are main player in all projects like GDI, which I will present, Genome of Europe, beyond 1 million genome plus, etc. And now I will present our genomic infrastructure. We have federation of 23 national nodes. Some nodes will be in operation, 15 nodes will be in operation in the end of 26. Some 3 nodes in deployment level and 6 on onboarding level. There is some links. We have developed in this project minimal metadata model for samples, for subject and diagnosis treatment, also some for environmental exposure and biomarkers. So we have some, how I say, cross-domain integration on this part sequence, and also metadata submission is part of DCAD. We extend this DCAD application profile. You have other links which are maybe important, and also I added also 3 links which are not part of this M+MG data model standards and ontology. One is ODRL, mentioned before, and another is Croissant ML. I think is very important for description of machine learning data sets, which is possible to use by AI training software. And also important part is this machine learning DCAT application profile, which is from the European Union for description of data sets. And maybe how this process look like. A researcher wants to find a data set, and when he finds a data set on the user portal, then log in. We have only AI authentication and search for variants, and then apply for this data, and data access committee approve or grant access or deny access according to his ethical permissions, and also according to description of his project. And if he has access to data, he has possibility to download data if he has permission, or to do processing on the site, for example, on institutional or national level, in secure processing environment, and also storage is secure storage. There is some standards which we use also. We use Duo as one of standard, and this is a user portal on European level, and we have on national nodes, and we have institutional nodes. In our country, our institutions don't want to share genomic data. Why? Because they haven't established processes for sharing. They scare to share data because they haven't signed this agreement for secondary use. And also, in our country, we don't have good legislation on this level. For example, in Estonia, they are much more open. Also, some other countries are also very strict in sharing data. So all has been done here now on institutional level. Only part of data, metadata, is sent to national level, as it is possible to search on beacon network for variants, and also on dataset level on this centralized discovery and access management in user portal. So this is our, how I say, situation. And we have built also one secure processing environment with secure storage environment on this genomic data archive on the national level. Also, there is possible to use national supercomputing network, and also it's possible to have access partly to our health data spaces. But this is only partly. This is from my point of view.
So are there any questions for either of the last two speakers? Yes, where's the microphone? Where did it? Oh, there it is. Thanks.
Thanks. This one's for Steve. The ODRL, are you expecting this purely to be descriptive, particularly of the parties, or is it intended also to enable interfacing with identity management systems like AAF or something like that?
That's what I...
Can you go to the mic?
Yeah,
Oh, yeah.
Yeah. That is the direction of travel would be to actually the identity provision. It's interesting that, sorry, let me just put up Milan's case. Some of the stack that he describes here, we have, in the work that we were doing here in Australia, and Ryan, do you want to put your hand up here? so Ryan got to pick up the work that I was doing. So we were using a combination of REMS, which is available through AAF here in Australia. It's work coming out of CSC in Finland, plus CI logon, plus essentially an integration to Dataverse for kind of putting that stack together. Now, we hadn't gone to the point of putting ODRL in that chain as well, but that's essentially it is intended to be implemented and to tie into the AAI sort of models.
The authentication part of
Yes.
this?
Yeah. I say, because some of what you can learn from essentially the parts that run EduRoam, for example. I know far too much about EduPerson, which is essentially the underlying part of that. You can kind of pick up and carry through in some of this model.
So that implies that a party definition could actually be a loose set of parties that actually have the access permissions granted.
Yeah, you could envisage that sort of thinking, and that's not long way down the track. It's there are certainly some work around that.
Over here.
Is it over?
Thanks. Hi, it's Kerry Levitt from ARDC. My question's for both Steve and Milan. Milan, you spoke about the health data space. Is that based on the actual data spaces like IDSA style model? Or is it a separate thing?
On different standards. But the main part on European health data space is this unified European health data record of a patient. With a lot of properties, they have their own model. On the dataset level, they have DCAT AP but mostly almost all is accessible through APIs. Now on the level of countries, some countries have implemented very well things, some a little bit less, but we strive to do this to 2030, that all data will be accessible according to ethical approval from a researcher, for example. Yes.
Okay, thank you. So the next part of that question is then for Steve. I don't know if you're familiar with the data spaces policy classes. So how compatible are they with, say, the data use ontology? Is that the right part? Am I getting the part right in this model?
I couldn't tell you right now.
Yeah.
As I'm familiar that they exist, I'm not that familiar with the content that's there. Okay. One of the efforts of a proposal we have actually amongst the group is to look at some of the integration across into data spaces in the EU environment, and it is the Data Spaces Association. So I think we will probably know more about that if that work gets funded.
Okay.
Yeah.
Thank you.
I'll All right, so Volmar again, and again starting with the genomics example, but then maybe we can expand on it a little bit more. You brought up the Global Alliance for Genomics and Health, and the GDI implements a lot of their standards. It's more or less a complete ecosystem of standards that supports many of the features that you described in the DDI, CDI. So I was wondering, I mean, is there maybe a case for taking all of the standards and see how they map to the more general one? And then are there other examples than the Global Alliance for Genomics and Health where there are more or less complete ecosystems that you could try to map to DDI, CDI?
I don't know some competing systems because, but I think that also there is a lot of holes in these standards for practical implementations. Because in process you need much more steps which is not defined inside standards. For example, I worked on University Clinical Center on rare diseases for implementation of these processes, and these processes are much more complex. But guidelines, it's okay, of course, but this standard like crypt for GH, it's good standard, but it's hard if you encrypt 2 terabytes of data. You need huge amount of time to encrypt this. So it's better in a lot of cases to do things on the intranet level without encryption, because if you analyze this data and prepare, for example, VCF file with 29 gigabytes, this is possible to encrypt, but 2 terabytes, it's huge amount of data to encrypt for every genome.
My name is Slava Tikhonov. I'm head of AI at CodeData, and I'm also co-author of both Cross-Sun ML and GeoCross-Sun. So my question, how you want to use it for health?
It is possible to use for health, of course, for description of data set. But, for example, in genomics, you need to describe much more things. In one sequence, you have many variants, and you need, for example, to describe things on the level of a person. Some variants you don't, how I say, you prohibit to send from location, because it's very sensitive personal data.
Mm-hmm. So it should be not Cross-Sun, it should be CDIF. And
yes.
Cross-Sun should be integrated with CDIF.
Yes, all is possible. Of course, it's possible. Okay. But on data set level, you have phenotypic data. It is possible to describe it Cross-Sun.
No, I mean, Cross-Sun was envisioned as a library. So it's a digital library, and basically it's navigation system for AI. And as soon
but
as
it's possible to add some domain specific...
No, as soon as you will find resource, you will land in specific node, and this node could be turned into expert knowledge, which is CDIF, and DDI variable cascade. So it should be a little bit different process.
So this is a kind of a general question. So I work with CCAN. I'm one of the co-stewards. I work with my company, Link Digital, does open data stuff. So that's kind of my perspective. We created a plugin for Croissant. I'm involved in the ML Commons datasets working group, and I'm kind of looking at various aspects of what we might want next. One of the things I'm keen to know is, metadata is often a statement of record about the data. It's like a record of fact. There are projects like within Creative Commons Signals about talking the after use of data and what signals might be available in terms of service. As it was discussed, is sort of like talking about how can I use the data that I might access. But because we can infer from signals in data sets, I'm just wondering to what extent CDF is looking at prescribing what inference is available from data and should not be available from data. So there was a mention of DCAT. There was a mention of DCAT and the recommendation for discovery, describing variables in data sets, the key variables. Wouldn't that same recommendation flow through to inference as well? So key inference that can be taken from data and then terms of service around that.
That's a tricky one, right? How do you quantify or even guess what are all the possible inferences someone might make?
So if I may, I'll try to answer. Maybe not answer, but thank you. Thank you for your question. Mercè Crosses, Codeira, and at the Barcelona Supercomputing Center. But it's just that one of the things, because I mean, maybe I think the talk happens on Wednesday morning, right? And tomorrow's also plenary. We'll have a little bit of discussion about data quality and the uses of how you describe a data set in a way that you think of what it represents and in what context it could be used for what type of inferences. But at the end, it's true that you cannot describe all the possible inferences, but what you can describe is what is it intended to be used for? It doesn't mean that there could be other options, but at least that it has that a data set was intended for this type of inference, and that's the closest that I could define for you that it's a good use of that data, is relevant and representative for that inference. If you're using it in another context, you need to be careful about how far it is from the representation of what your research question, right? For representing or being relevant for the research question. So I think that's part of the description of data quality, that it's the ISO has put together some standards on data quality that help towards that.
Does any of that come under the scope of the data use ontology? Sort of.
Probably not. I would say not yet.
Yeah, I think it probably describes what you're allowed to do,
right?
Or what, rather than what
it might do. Data quality more than
data
use.
So the
like
question
is that data good for what?
Yeah. So whereas the duo is really focusing on these are the rules that you have to follow. Fundamentally, you can use it for this, you may use it for this, you're not allowed to use it for this, and the flow through those other combination of standards as well.
Back there?
You're cheering, Steve.
Yeah.
Hi, thank you for a great presentation. I'm Sitya Pramana from Indonesia, STS. Just wondering whether it's outside of the technical. Is there any regulations within Europe? How do you share genomic data within countries in Europe, also outside Europe? Because now Indonesia, for example, we are still regulating how we can share the genomic data, especially outside countries within the researchers and also within the students' associations. Thanks.
Problem is sharing data inside Europe,
yes.
not outside Europe, because everyone, it is possible to, for example, if you have ethical approval, to do something on the site, for example, to send a program and we test this program and then produce the results and send you back results on our cohort, for example, which you want to have. But we, before, need to, filter this data set. Also, so it's very hard to do things now, to share genomic data, human genomic data. It's very hard. And also, another thing is maybe important granularity of these queries. For every query, for example, if you want to have individuals with lung cancer, with, for example, from 40 to 60-year-old men, and maybe some other phenotypic data also, it is hard to share some of these individuals, because if you have less than 5 individuals, then you have problem in Europe also. But whole genome is not possible to share.
I'm going to reflect a little bit on, say, this isn't a problem that's specific to genomics either. I spent quite a bit of my career actually working with BPS in Indonesia on access to other content from Indonesia, including census data from Indonesia. So you have sort of questions, say, it's what I quite like about the EOSC, the framework, the sort of the legal, organisational. The legal parts of it, I say, were, for example, it could be shared essentially at very low cost. The operationalisation of that at the organisational level, though, is it depends somewhat on policy choices that are made inside the organisation. So there's the interaction between the regulatory framework and what the particular organisation wants to do there, and you kind of have to be able to recognise and account for both of those areas. So as I say, it's not, there are specifics to genomics, there are specific to social science, which is where the community that I'm from, but there are certainly issues that and that's the point of CDIF, is the cross-domain parts of this are what are those things we can extract out that are essentially the similar cases across domains, so that we can focus then on what are the domain-specific requirements we have that we have to be dealing with at a domain level.
So time is running down, and before we quit, I just wanted to get a little bit of feedback about this basic idea. So we've talked about a lot of different kinds of information that we want to be able to know about data sets in the metadata. And, we have some basic metadata schemes, the discovery profile, that account for some of this stuff. The question is, what this in terms of how do we implement this modular metadata in a way that a metadata consumer can know how to process a metadata record, or on the other hand, from the point of view of a metadata provider, you might be able to offer metadata with various profiles. We talked about using the DC terms conforms to within the metadata record. There are other possible approaches here. You can put information in HTTP headers for responses. The W3C semantic data on the web group has a proposal about content negotiation by profile, where you could actually, in an HTTP request, say, I'm interested in this profile, and then that determines the content and the serialization of the response you get. Do people have any feedback or ideas about alternative approaches? Are these workable? Is this too complicated? Are people, any thoughts about that? I'd be really interested in hearing any comments or other questions if people have.
So my general, everything's been great, so awesome information. My general feedback is it seems like if you're thinking about the data commons or data collections, areas where a whole bunch of data could sit and it's enriched with metadata, there's kind of two classes of users. There's automated agents that would go in there with intent to do stuff and extract stuff. And I think I don't see enough to support that yet. So agentic actions coming in, and then within that pool, operating or interoperating, in kind of like a safe space. It seems like there should be some sort of perimeter once people can get in, and it's a trusted agent, let's say, with a trusted intent. There would need to become some sort of evidence for or against that they're sticking to their terms as an actor. So the duo model and the access, the permissioning model, all that sounds okay, but I think you got to get people into a pool or agents into a pool. That's my main feedback. That just there's an area of change to manage.
Right. Cost.
Thanks. I think in some way following up on this, because I think that this provides the set of metadata to be able to do something like that, but you still need to build a lot of the tools that help you then to make that usable. I mean, made a lot out of it, right? So, but I think this is the place to start. So I think it's a very good start. I was one question, and maybe it's more directed to Steve, is that when you see the integration of these three different approaches, right, to data, I mean, the VRL, the duo, and the data privacy. What would you say you got? What is success for you in this case? What would you want? I mean, in a way, connected to the previous feedback. That what would you want people to be able to do in an automated way that now they cannot do, and how would what would be the perfect outcome?
Yeah, that's a really good question because it connecting the dots. So, on a day-to-day basis, we operate TRE and a discovery portal and a dissemination portal for downloadable data. So we have a mix of all the of the different parts that are there. So I'm going to answer both questions. Which is, so one of the points here is, what's the best pathway for someone to go through to get to what they want to? How do they get to it in the as automated a model as possible? And then once they're in there, as you say, in some cases, and it's not in all cases, in some cases you have to follow what's happened there. So there's an audit trail you need that's there. Now, I don't think we've thought at all about the audit trail side of it in this context, but I can tell you day to day, that's a big part of my responsibilities, thinking about what comes out the other end. And that, there are related projects actually happening that kind of have started to explore that. There's a program in Dare UK, in the UK, which is partly thinking about getting stuff out the other end. For example, what do you need to do through that process? So that sort of integration, I think, becomes an interesting question as you go through. To go to the sort of what's success here, getting in is actually, there's a massive, massive administrative burden involved with, say I have a team of, it was 6, I think, 6 people whose job it is to manage, access requests into a TRE system. Part of their responsibility is to keep people out of it. Sometimes, no, you can't have it. Sometimes there is a better option here. The administrative burden that comes from running all of that, a lot of that, based upon the rules that we're talking about here, should be able to go, this is where you need to go. We're actually working on a framework, a model at the moment, taking some of this, which says you can go here, and and you can enter the access request system that we're talking about, or you could, based upon the risk of the data that you're interested in, take these variables out. Often might be low-level geographies, low-level temporal resolutions, etc. As good examples. If you take those out, you can go over here and you get it right now. So the success here is about moving the burden of managing access to the places where it needs to be done, not where we're doing it right now, which is we don't have a better way of actually working our way through the system itself. That sort of streamline. And it doesn't have to be fully automated, to be clear. You can still have human decision-making and accountability in that process. But that is the framework that we're really thinking about.
All right, one more comment. We're about out of time. And
This is maybe it's a sort of meta comment on all this, but is part of the plan ultimately that CDIF, even though it's not inventing new standards, will have a set of specifications corresponding to each of these profiles? Because the thing that worries me, as I'm thinking about the I and the R of FAIR, is that I'm still assuming a certain number of conventions that people, like DC terms conforms to, that we are using that for a particular purpose. And that at the core of CDIF, there's certain things that any publisher or consumer of CDIF has to follow. JSON-LD conforms to, etc. And then for each of the individual profiles, you could imagine CDIF publishers that have only got as far as fulfilling a subset of those, and indeed some repositories or tool sets that only know how to leverage the value in some of those. And so thinking of it in terms ultimately as a kind of set of specifications, hopefully fairly lightweight ones, would probably help a lot for communicating how we do this.
I think that's how we're thinking about this, is that basically these are specifications about the problem with most of the things like Dublin Core, ISO, all the standards that are out there still have a great range of flexibility in how people use them, and interoperability is still a challenge. And so the idea is that we can provide a set of conventions about specifically, this is how you use this JSON LD, schema.org, to convey the information so that if it says it's a CDIF discovery metadata record, you know that the conforms to is going to be about, have a specific use, and you know how to interpret things, and there's some guidance there on exactly what to do, which right now is kind of Wild West. Simon.
Yeah, no, I mean, just to completely agree, I was going to say pretty much the same thing a little bit differently. I mean, we want to point people towards good practice in adopting particular standards. We then want to provide implementation guidelines. And then, yes, more specifically, we want to say, do this specifically and do it in a way that we can test it with shackle and shapes, etc. You know, that we can have a conformance layer. And I think to do it in that incremental way, recommendation, guidelines, implementation guidelines, and then even more specific is the right way to lead people on. But ultimately, if we don't have a very firm recommendation, we won't achieve interoperability. You know, it is as simple as that. It has to be by agreement. It has to be based upon standards. It has to be implementable so there's clear guidelines. But ultimately, yes, we want to be able to check, are you conformant with this particular recommendation on how to implement? Yeah.
Steve had a closing comment from Steve.
I would say that take that even one step further, which is to say, as I say, if you think about machine actionability being that essentially the direction of travel, you know, is we cannot scale in the way that we want to do a lot of these things. Then how does that get instantiated in some of the tool, you know, the tool chains and technology stacks that we're actually talking about there? So we reference CCAN, you know, we've been talking to Dataverse, etc. What would that do? What could you embed inside some of the tool chains that we actually have that would allow taking the humans out of the, you know, the manual curatorial labour that's there of what is essentially rather, you know, low-level work and focus on the things that actually require human intervention. So we're embedding it in the automation systems such that you then are focusing on the things that we really ought to be doing and that we know that we have to be able to do for governance and for other reasons.
Thanks. We're out of time.
Just one question.
Okay.
Would it be conceivable to have a test environment for offers to see that they are CDIF compliant? Would it be conceivable?
To have what sort of?
Test environment.
Oh. Well, that would be ideally, if we have shackle rules in JSON schema, would be the kinds of things that would be used for validation, I think. So we're out of time. Thanks, everyone, for attending. There is a poster, P45, that's related to this, if you're interested in more discussion about that this evening. And thanks a lot for coming, and we'll be around. Let us know if you can reach out.